Hello everyone. In this video I am going to teach you different types of linked list. Now let's see what are the different types of linked list. There are four types of linked list. First one is singular linked list. Second one is doubly linked list. Then third one is circular linked list. Then fourth one is doubly circular linked list. Now let's see this one by one. Now first let's see what is singular linked list. Now what is singular linked list? Singular linked list means I have taught you in previous lecture itself. Linked list means if you call normal linked list means that is singular linked list. Now see what is singular linked list. Singular linked list means it contains n number of nodes. Suppose you have to store n number of elements in this linked list. Then you have n number of nodes. Suppose see now I want to store three elements in this linked list. So I am creating three nodes. See, this is first node, this is second node, this is third node. Suppose let's say the address of this first node is 100. For example, I am saying this 100. Now for this node is 200. Let's say address of the second node is 200. Then address of this third node is 300. Let's say this for example. Now in singular linked list, each node contains two paths. See, each node you have to store three elements. In that each three nodes you contain two paths. So what is this first part? First part stores it's a data part. In this data part you can store the data element what you want to store in this linked list. Suppose I am storing here suppose 7. The first element which I am storing in this singular linked list is 7. So I am storing it in data part. Suppose here 8. I am storing second element is 8. Suppose here 4. Third element is 4. So I can store data part in this first part. Now what is this part? This second part is known as pointer. Pointer stores the address of next node. See, suppose in singular linked list you have to create a link because this is the first node. You don't know which is the second node. This is the second node or this is the second node. So to identify which is second node, you have to create a link between them. So now if you create a link, see this is first node, this is second node. You can find. So how to create this link? For that you have a pointer. This pointer stores the address of next node. See the second node is the address of second node is 200. So I can store the address of this node, that is 200 over this thing. Now what is the address of third node? It is 300. So I can store 300 over this pointer part of previous node. So 300 I am storing here. So if I write here 300, it creates a link over here. Now this is the last element. 4 is the last element. This is the last node. Now after this no element is present. So you for this pointer address you will write here 0. 0 means no element is present after here. So no link will be created after this. Now see, now you have another pointer known as head over here. What is this head pointer? Head pointer stores the address of first node. First node is this part. So address of this first node is 100. For identifying first node, you are having a pointer head which stores the address of first node. Address is 100. So I am writing here 100. Now head pointer points towards the first node. This is singular linked list. See, in singular linked list, the traveling is in forward direction. See, first element is 7, then you can go to second element 8, then third element 4 you can go. You can't go in backward direction. So this is singular linked list. Now let's see how to write the structure for the singular linked list. How to write the structure of each node. Let's see. Now I am writing the structure of each node. So I am writing struct node. Now I am defining the structure of each node. See, suppose I am taking this node. What is the structure? It contains two parts. First part is data part and second part is pointer. So I am writing here, see, int data. So it creates a variable data and it is used to store data value in that. Now what is this int? Int means integer. Here I am storing integer values. So I am writing the type of data is int. Now if you want to store decimal values over here, you can write float. If you want to store character values, you can write char. So this is how this is the first part in this structure of node. Now see, second part is pointer part. So I'm creating a pointer. See, now pointer, the symbol is used to define a pointer. See, now I'm naming this pointer as next because this next stores the address of next node. So see, you can name anything. I'm naming it as next node. Pointer next. Suppose this pointer next points towards the address, points towards next node. Now see, the next node contains the same structure as previous node. It contains same structure. This contains two parts. Same two parts is there in first node. So I'm writing a struct node. So it creates a pointer next which points towards a struct node. That struct node comes again back and it creates a structure, same structure of two parts, integer data and struct pointer. So this is how you should create define a structure of each node in a singular linked list. Now let's see what is doubly linked list. See, now what is doubly linked list? It's almost same as singular linked list, but see, in singular linked list each node contains two parts. In doubly linked list you have three parts. In each node you have three parts. See, suppose now I'm storing suppose three elements in linked list. See, I'm creating three nodes for that. These are the three nodes to store three elements. Now this each node contains three parts. So see, so I have created three parts in each node. Now what is this first part? This first part is called pointer part. This first pointer points towards the address of previous node. Here no previous node is there, so we can mark it 0. Suppose let's say the address of this node is 100, the address of second node is 200, the address of third node is 300. Let's say for example. Now see, suppose this second part is data part, this middle part. In middle part you can store the elements which you want to store in the linked list. Suppose I'm storing here 7, I'm here storing here 8, suppose I'm storing here 4. Suppose these are the elements which I should store in this doubly linked list. So this middle part is data part. What is this this part? This first part is pointer part which points towards the previous node. No previous node is there. This is the first node. So how you want to define this is the first node? You should have a pointer head same as this. So I am creating a pointer head which points towards the first node. This is the first node. So address of first node is 100. So I am pointing here 100. Now see, the address, no previous node is present here. This is the first node. So here you want to mark 0 because this you can't point anything before this. Now see, this third part is known as again pointer. But see, this pointer is used to point the address of next node, same as the singly linked list. Now see, the address of second node is 200. So I am storing here 200. Now it creates a link in forward direction so that you can identify this is first node, this is second node. Now see, this is the pointer which stores the address of previous node. Now so address of previous node is 100. So I can store here 100. So what? It creates another link which goes in backward direction. Now see, this part is known as for next node which stores the address of next node. Now address of next node is 300. So I am writing a 300. Now it creates a link in forward direction. Now this pointer part stores the address of previous node. The address of previous node is 200. So I am writing here 200. So I am creating another link in backward direction. So now see, this is the last node. No element is present after this. So this pointer stores the address 0 because this pointer stores the address of next node. No next node is there here. So 0. Now see, in previous singular linked list you have seen the traveling is done in forward direction. Now if you are in 7, this first element, then you can go 8, then 4. In forward direction you can't come 4, 8, 7. But see, in this thing there are two directions, two links are there. One is forward link and another is backward link. So you can go here forward direction 7, 8, 4, then you can come back 4, 8, 7 like this. Now see, there is one disadvantage in doubly linked list. What is that disadvantage? See, in the singular linked list, you have only two parts. One is data part and another is pointer part. So only two spaces are required. But here see, each node contains three parts. The two pointer part and one data part. So here more memory. The disadvantage here is more memory needed, more capacity or more memory. So this is the disadvantage over here. Now let's see how to write the code for structure of this node, structure of each node. See, I am defining the structure of each node. So struct node. Now what are the structure of this node? It contains two pointer part and one data part. So see, I am writing a linked data. Now this data variable is used to store the data value which is integer. So I am writing a int. The type of data is integer. So I am writing a int. Now see, there are two pointers. First pointer is previous pointer which stores the address of previous node. See, so I am writing a pointer pre. Pre means previous. I am naming it as previous. You can name it as anything. Now I am naming a pointer which points towards a previous node. That previous node also has the same structure of this node. So this is same as the structure of this node. So I am writing a struct node. So this pointer goes back and it creates the same structure. Now the another pointer is the which stores the address of next node. So see, I am writing a pointer next. This pointer points to points towards a node which has the same structure as this second node. So I am writing here same struct node. This node contains three parts. Same this node also contains three parts. So I am defining same struct node. Now this is how you define the structure of doubly linked list. Now let's see what is circular linked list. See, we can convert this. It's almost same as singular linked list. We can convert this singular linked list into circular linked list. Let's see how. See, what is circular? Circular means, suppose this is the last node. You are traveling from starting node 7, 8, 4. Then this is the end point. Suppose you want to make it circular. How you can make? After this 4, you are connecting this pointer towards this node towards this. If you connect, what will happen? You will travel 7, then 8, then 4, then again 7, then 8, 4. It becomes circular. So this is circular linked list. So this, now how to create this loop? See, now here in singular linked list, no node is present after this third node. No element is present after this third element. So I am marking here at pointer part, I am marking here 0. See, now after if you want to make it circular, you want to point this address in this pointer part, you want to store the address of next node. What is the next node after this third? It is first node. So what is the address of first node? It is 100. So I am storing here, instead of 0, I am storing 100. Now it creates a loop. It creates this pointer stores it points towards the first node. Now it became a circular linked list. Now this code, how to define the structure, create a structure of this each node is same as singular linked list. Now let's see double circular linked list. Now how can we, it is same as doubly linked list. How can we convert doubly linked list into doubly circular linked list? See, now to make it circular, the last node should the pointer of last node, the next pointer of last node, this is previous pointer, this is next pointer. Next pointer of last node should point towards the first node, so that it becomes circular. So see, now here no node is present after this, so I am marking here 0. But if you want to make circular, this pointer should contain the address of first node. What is the address of first node? It is 100. So I am marking here 100. Now see, it creates a link in forward direction. Now this is the third element. After this it goes into first element. Now see, now you created a link. Now this link is not enough. Now this is doubly linked list. You should have two links. So see, now here it is defined as the first node is this 100 is the address of first node, 7 is the first element. Now no element is there before this 7, so I am marking the pointer is 0 in this first node, previous pointer is 0, because no element is present in before this. Now, but if it becomes circular, the previous node of this first element is what? This 4. The last element is the previous element of this first node. So instead of 0, I should mark the address of last node, 300. So I should mark it 300. If I mark 300, what it becomes? This previous node point, it creates a backward link which points towards the previous node. Now previous node of this first node is last node. So I have created a 2 doubly circular linked list. This is how you should convert circular this doubly linked list into circular doubly linked list. Now to define this structure of each node, it is same as doubly linked list. This is how you create these are the different types of linked list, and this is all how you should create a different linked list. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.